Here in this video I would like to show you basic functionality of 2-position and 3-position controller. I would like to go into details and show how is it different with a 2-position with hysteresis and without, and the same with 3-position controller. Okay, so I start with a simple graph. In Simulink, this element, here we focus on the relay block element that we put into our closed loop system. Such a relay block element has few variables to set. First of all, what we need is a switch on point, switch off point, output when off, and output when on. Those are the variables we need to define when we model such a system. Okay, we start with the 2-position controller without hysteresis. What I mean here? Here we see the error. Depending on that error, the controller is either on or off. It changes in state into yes, either on or off. Here we define switch on or off point. In the case when we have no hysteresis, the switch on and off are the same. Switch on and off point are the same. So E dash is switch on point is equals as also switch off point. We define also, as I said before, output when off, and output when on. Okay, so here we can see our controller is still off before it gets the switch on point. So our output is simply this value, and here it achieves the specified value, and we go and we have output when on. Two possibilities. Okay, with the hysteresis, it looks slightly different. Hysteresis in the controller means that switch on point is different than switch off point. It's good for a controller because it eliminates very frequent switches of the controller. Therefore, it won't be damaged as quickly as without. So again, we have two possible outputs, element outputs, and here we have, in this case, we have two variables here. Switch on point E2 I will define it as switch off, and this will be switch on point. Okay, and again U1 is output when off, U2 is output when on. So here our output looks the same as in the previous example. So generally, when I count the number of variables I need to define for a two-position controller without hysteresis, those are 3. As you can see, output when on, output when off, and switch on and off point, which is basically the same. And here I need 3 variables: output when on, output when off, and switch on and switch off point. I move to the 3-position controller. Without hysteresis first. Therefore, we have only for the first relay element, we have for this one, we have switch on point, point, output when off, when on. Okay. And for the second relay element, we define also. I use different notation so that I can distinguish easily. On point equals switch off point. Okay, and then I need also the same output when on. Okay, as you can see here, when I'm in this state, here in this state, both of the switches are off. Therefore, our output looks like this. I take the value, this one and this one. Both switches are off. Here, I already entered. The error already grew up to this value. Therefore, switch first is already on. So my output here in this point equals to this. Why? Because I take from the first switch, I take output when on, because it's on, and from the second switch I take output when off, because it's still off. And here, accordingly, here both switches are finally on. I have achieved both this one, and here I'm over even this value. Therefore, both switches are on. And it looks like this. This value plus this value. So how many variables we need to define such a system? 5. 1, 2, 3, 4, 5. Now I will move to the most complicated, most complex case, when I have free position controller with hysteresis. U2 and U3. Okay. So here, again, switch on and switch off. Switch on value, switch off value for the first controller. I will write it shorter, switch on, out, off, output off, U2 put on, and for the switch off, switch on, output off, output on. Okay, so as you can see, here we have in both of the switches we have two variables that define first switch on, switch off point and switch on point, because we have hysteresis. And in the first case, okay, both switches are off. Therefore, the output simply equals to this plus this. Both switches are off. Here, finally, we move a step further, where the first switch is on. Therefore, the output is first is on, but the second is still off. Still off. And finally, both switches are on. The error has achieved, oh, here I missed the notation, has achieved such a value that finally both switches are on. Therefore, it looks like this. I hope you understand. Thank you. And I wanted to mention that here, as we needed 5 variables to define the system, here this number grew up to 7. 1, 2, 3, 4, 5, 6, 7. So again, 3 variables, 4 variables, 5 variables, and 7 variables to define those controllers accordingly. Thank you.